Hello friends, this video on structure of atom part 37 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 36. Let's take some example here. The first one says that you write the electronic configuration of H minus ion. So H minus will have how many electrons? 2. Na plus will have, sodium has 11, 11 minus 1, 10. O plus, oxygen has 8, 8 minus 1, 7, and F minus, fluorine has 9, 9 you add 1 because negative charge, 10 electron. Correct. So let's start with H minus. H minus will have 2 electrons. So 1s will be sufficient for this guy. So 1s2 will be the electronic configuration of H minus. Na plus has 10. So 1s subcell, 2s subcells, and 2p subcell is also required. Correct. 10. So let's distribute. First, second, third comes here, fourth, fifth, sixth, seventh, eighth, ninth, 10. So the electronic configuration will be 1s2, second S cell has 2, 2p cell has 6 electrons. This is the electronic configuration of Na plus. Similarly, O plus has 7 electrons. So 1s, 2s, 2p. So 1s will have 1, 2, then third, fourth, fifth, sixth, seventh. This is how the electronic configuration of O plus will look like. It will be 1s2, 2s2, 2p, 3. And you see O plus is stable because it is halfway. If you see F minus has 10. So let's again write 1s2, 1s, 2s and 2p. Right. So if it is here also, if you see this was 10 and this was 10, the electronic configuration will be all the same. I'll just show you. 10 electrons. First comes here, second comes here, third comes here, fourth comes here, fifth, sixth, seventh, 8, 9, 10. So it will be 1s2, 2s subcell has 2 and 2p subcell has 6. These are the electronic configurations of all this ions. Second question is, what is the atomic number of element whose outermost electron represented by 3s1? Please note, if the outermost is 3s1, that means the electronic configuration will be something like this. I'll write, see, 1s is the lowest energy, then I have 2s, then I have 2p, then I have 3s, right? Like this, it goes up. So it is 3s1, that means the electronic configuration will be something like this. 1s2, 2s will be all filled, 2p will be all filled, and then I have 3s1. Correct? This will be the electronic configuration of this element A. So the total atomic number is 2 plus 2, 4, plus 6, 10, plus 1, 11. So the 11 is the atomic number for A. Let's take B. For B it is 2p3, this guy. So before 2p3 I have 1s and 2s, they should be all filled. So I get 2p3. If you add 2 plus 2, 4 plus 3, 7. So this guy is 7 atomic number. Similarly 3p5 is or it's 2p5. It's 2p5 actually, it's 2p5. So 1s2, 2s2, 2p5. So before this I have to fill everything. So this becomes 1s2, 2s2 and 2p5. Electronic configuration. This becomes 5 plus 2 plus 2, that is 9. Let's take one more question. Which other atoms are indicated by the following electronic configuration? Helium 2s1. So if you see, helium is nothing but 1s2. That's all, right? So helium 2s1 will be nothing but 1s2, 2s1. So what is the atomic number? 2 plus 1, 3. So atomic number 3 is what? Lithium. So that is my answer. This is done. Second is neon 3s2, 2p3. So neon I know is Or I can directly say neon is, what is the atomic number for neon? 10, 10 plus 2, 12 plus 3, 15. So neon 3s2, 3p3, atomic number is 15. Correct? So atomic number 15 is what? Phosphorus. The second is argon 4s2, 3d1. So argon atomic number is 18. In 18 you add 3. So atomic number becomes 18 plus 3. That is what? 21. And 21 atomic number is for. And that is my answer. Easy only. Which is the lowest value of n that allows g orbit to exist? The question is, which is the lowest value of n that allows g orbit to exist? See, I have s orbit, p orbit, d, f, g orbit, right? For s orbit, L is nothing but 0. This is 1, 2, 3 and 4. And we know that n has to be 1 more than L, right? So for L to be 0, the n minimum value of n is 1 because it starts from n. For getting a p orbital, the minimum value of n is 2, right? It starts with 2p1. For getting a d orbital, the minimum value of n is 3. Why? Because it has to be 1 more than L. For f, the minimum value I saw was 4. So for phi, the minimum value will be, for g, the minimum value will be 5. So the minimum value of n that allows g to exist is n is equal to 5. Because n is always L plus 1. Correct? An electron is in one of the 3d orbital. Give the possible value of n, L, ml. So I am saying my n is equal to 3. For n is equal to 3, I have 3 options. L can be 0, 1 and 2. If it is 0, it is S. It is 1, it is P. It is 2, it is D. That's how it is. The tree structure which I told. For n is equal to 3, I can have 3 values of L. And 0 signifies S. 1 signifies P subcell. And 2 signifies D subshell. Right? The question is, an electron is in one of the 3 d orbitals. So if you see, for this d is equal to 2, I can have how many orbitals? -2, -1, 0, +1 and +2. Hope you understand. See, for any value of L, I can have this ml to be -L to +L. So -2 to +2. So one electron is in one of these orbitals. Correct? I have to find the possible values of n, L and ml. So in all these cases, my n is 3 always, L is 2 always, but my ml can be -2, -1, 0, +1 and +2. And that is my answer. Hope you understand. See, in the tree structure, what we told was, for a given value of n, I can have lot of value of L. So for n is equal to 3, I got 3 values of L. For L is equal to 2, I got these 5 values of ml. Structure I got. The question says that electron is in one of these orbitals of 3d subshells. Right? So, 3d subshells. So these can have any of these ml values. Here a neutral atom, actually, because it is telling atom, so I'll assume it is a neutral atom, it is not ion. A neutral atom of element contains 29 electrons, 35 protons, neutrons. We have to find the number of protons. Since it is neutral, I can say that number of electrons is equal to number of proton. And number of electron is 29, so the number of proton is also 29. First part is solved. Now I have to find the electronic configuration. So electronic configuration depends on the number of electrons, 29. Right? So I'll write the electronic configuration for 29. So again, let me write the order of increasing order of energy. I'll write 1s, 2s, 2p, 3s, 3p, 3d. Then I have 4s, 4p, 4d. So I'll take first 1s first, then 2s, 2p, 3s, then I'll take 3p, 4s, like this. So let me write first the increasing order. It is like this: 1s, then I have 2s, then I have 2p, right? Then I have 3s, then I have 3p, then I have 4s, then I have 3d, and then I have 4p, something like this. Just 29. So this will be 1s, then I'll have 2s, then I'll have 2p, then I'll have 3s, then I'll have 3p, then I'll have 4s, then I'll have 3d, right? D will have how many? 10. 2, 3, 5 orbitals, 10 electron, 3d. Then I have 4p. So let me fill the electrons. There are 29 electrons. 1, 2, 3, 4, 5, 6, 7. Pairing start. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 20. Sorry, I'm not doing correct. 20 is fine. Then after that, let me remove this. It is 3d orbital. The pairing won't happen first. So 20 is done. 21, 22, 23, 24, 25, 26, 27, 28, 29. 29 is done. But now you see this guy has 9 electrons. If it gets 1 electron, it will become stable. So what it will do, it will take 1 electron from 4s. Right? So it will come here. And this is half filled. So this will also be stable. So the electronic configuration will be 1s will have 2, 2s will have 2, 2p will have 6, 3s subcell will have 2. This was, I think, 3p. Yeah. Then 3p subcell will have 6, 4s subcell will have 1, and 3d subcell will have 10 electron. And this is what the electronic configuration will look like. Correct? Because of the half-filled stability, the electron jumped. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.